Let me show you an example how to calculate the frequencies, relative frequencies, and densities using the real data. I will use the same values as in the example about quartiles and box plots. And let's assume it's 10 glasses of water and chloride content in each glass in milligrams per liter. Okay, so I will start with creating a plot, a dot plot, a simple dot plot. So we have like 50 here, then we have 60, we have 70, and we have 80, the middle points. Then let me show the data points. So the first is 53, somewhere here. Then we have 60, 61, and 61.5 and 62. It will be 3 points located very close to each other in this part. Then we have 66 and 67, 66 and 67. We have 71 and 71.5. Then we have 74, and then we have 81.5, somewhere here. So this is our data. Okay. Now, how many beans to use? Let's use, for example, 6 beans. Okay. So number of beans, its number of beans will be 6. And we will use the same range as in the slides, from 52 to 82. So what it means? It means that we have the total range is 30. 82 minus 52 is 30. Then the width of the bean is 30 divided to the number of beans, which gives us 5. Okay, so this is the width of the beans. Okay, now I can first of all calculate each bean, the boundaries for each bean. Well, it's 52 to 57, so I just add 5. Then it will be 57 to 62, 62 to 67, 67 to 72, then 72 to 77, then the final bean, the bean number 6, will be 77, and then 82. So these are our beans: the first, the second, the third, the fourth, the fifth, and the sixth. So these are our beans. Okay. Now let's calculate the frequency, the real frequencies. The real frequencies. Well, let's find how many values we have between 52 and 57. So the 52 is somewhere here, and the 57 is somewhere here. So we have only one value. So I'll just write it down. Then 57 and 62. And we have a very interesting, the boundary of the bean 62 is the same as the value, but it's the right boundary. So it means that 62 will go to the next interval. Okay, so it means that we have only 2 values here. And then from 62 to 67, again we have the same situation, 67 and 67. Okay, so we have 67 as the right boundary and 67 as a value. Again, similarly it goes to the next. So we have only 2 values here. It's 62 and 66. Then from 67 to 72 we have 3 values. It's 67, 71, and 71.5. So it's 3 values here. Okay. Then 70 to 77 we have only 1 value. It's 74. This one. And then similarly we have only 1 value here. So we can count how many values in total: 1, 5, and 5. So we have 10 values in total. So the sum is equal to 10. So that's correct. Now let's calculate the relative frequency. The relative frequency. In this case, it's very simple because we have the total number of values is 10. We just take the frequencies and divide to the number of values. So it will be 0.1 here. It will be 0.2 here. 0.2, 0.3. 0.1 and 0.1. So the total sum of the all relative frequency is always 1, and you can check if this is correct. Okay. Now we need to calculate the densities. Okay, and you remember that density is a relative frequency divided to the width of the bean, and we know that the width of the bean is 5, so we just need to take 0.1 and divide it to 5 and so on. So in this case it will be 0.02 and 0.04, 0.04, 0.06, 0.02, and 0.02. Okay, so that's the densities. Now we can make a histogram. So first of all, we need to make the X like this. Then I will define this 6 beans. It's the first bean, second, third, fourth, fifth, and sixth. So we have 6 beans. So we have 52 here, 57, 62, 67, 72, 77, and 82. Okay. Now we define the x, the y-axis, this one. Okay. And I will use the relative frequencies in this case. So it's 0.1. This will be 0.2. This will be 0.3. Okay. So this is relative frequency. I'll just write it here. The relative frequency, and this is the x values. This is in milligrams per liter. Okay. So we are ready to make the bars. The first is 0.1, so it's this one. Then we have 0.2. Then we have another 0.2. Then we have 0.3. Then we have 2 times by 0.1. 0.1. Okay, so that's the distribution histogram for our data.